Example 2, we're going to graph a cube root function. So here's my problem. We're going to graph y equals the negative cube root of x minus 1 plus 1. And if we look back at our cube root parent function, remember that it goes both directions forever. So the domain of this cube root function would be all real numbers. Goes to the left forever, goes to the right forever. So when I graph the transformation here, let's start off by making my table. And remember again that we can cube root negative numbers. The cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1, and the cube root of 8 is 2. So I want these 5 points shown in my graph, and the transformations of those points reflected in my graph. So if I look at the transformations that happen here, this minus 1 is going to translate our graph right 1. This negative on the outside reflects over the x-axis, flipping upside down. And then our 1 here at the end moves up 1. If we follow our order of operations for our transformations, we need to move our graph right 1 first, which means we need to add 1 to all of our x values. And then reflecting over the x-axis affects our y values. All of our y values we need to take the opposite sign of. So this would become positive 2, positive 1, stays 0, negative 1, and then negative 2. Move up 1 now, we add 1 to each y value. And then these would be my points. This is a negative 1 here. These would be my new points that are graphed. Negative 7, negative 7, 3. I have to go off my graph a little bit here. 0, 2, 1, 1, 2, 0, and then 9. So this would be 6, 7, 8, 9, negative 1. And we have to estimate a little bit there because, again, it went off my graph. But connect our dots. Again, this is kind of an awkward thing to do sometimes since that graph is so skinny. The big thing, though, is that we have those points shown, that I can see those 5 points, right? But that's our graph of a cube root function.